Hi, Zach. Thanks so much for spending time with me. It's rare to talk to someone that has the same challenges, the same type of background, and that created a company that's very close to what we do. So maybe by way of introduction, maybe you can talk a bit about who we are and what we do and why are we chatting?
Yeah, absolutely. Well, I'm also really excited to talk with you for the same reason. So, working in sort of synthetic biology in the consumer space, it's really exciting space and kind of I think where the future is headed. And so it's fun to be talking with a fellow trailblazer kind of in the consumer symbiotic space. Yeah, I can start. I can give you a little bit of kind of history of ZBiotics and kind of what we do. So, ZBiotics, we make genetically engineered probiotics. And so basically, we take a probiotic bacteria, and then which is generally speaking, already performing thousands of biological functions, and we essentially use genetic engineering to have it perform one additional function on top of the functions it's normally performing, and then that function that we engineer to make or perform, excuse me, is something that is useful to you. And so then when you ingest this bacteria and it passes through your gut, performs all the normal functions it performs, and then it performs our additional function. And it does that kind of agnostic to what's going on in the gut. And so it just kind of floats through your gut, performs its function, and then it passes out the other side. I thought that was a really exciting and powerful idea, and I really wanted to bring this product or this technology to consumers. So rather than kind of addressing diseases, we wanted to address kind of problems that people deal with in their normal kind of healthy lives. And so our first product is a probiotic that is genetically engineered to break down the toxic metabolic byproduct of alcohol that makes you feel not so great the day after drinking. So the idea is that you take our probiotic before you drink alcohol, and then it performs this function to break down this byproduct called acetaldehyde while you're drinking. And then the next day you wake up and you feel better and you can get more done and enjoy your Sunday morning, whatever it is. And
Yeah.
so our vision is to kind of like have a whole bunch of these probiotics to do all kinds of things. So that's kind of where we're at and what we're doing.
Yeah, when I first heard about what you guys are doing, I was just fascinated. I thought it was a fantastically elegant idea to, change the gut bacteria to add different characteristics, basically. I think it's great. And I think it's a very much needed step towards the consumer because and when we talk about genetics, genetic engineering, synthetic biology, people think about medical application, pharma, etc., but not necessarily everyday lives. And this resonates as well very much with what we do. So at Neoplants, what we do is we engineer plants to allow them to absorb and metabolize indoor air pollutants, specifically volatile organic compounds. And same as you, this is kind of the first application that we have in mind that you can use on every day. The goal is to put a plant in your bedroom and have it lower the amount of pollution you have that you're constantly breathing. So the problem we're tackling is the problem of indoor air pollution, which is 5 times higher than outdoors due to these compounds. And so I'm very fascinated by the concept of putting GMO in people's routine, people's lives, people's homes. It's something that might sound a bit provocative, but I think it's high time that people understand what is a GMO, what can it do, and try to kind of tell the difference between what GMO has been used for historically and what we can actually apply it to in everyday's life of people. So
Absolutely. Yeah. I mean, I love what you're building. I'm so excited about same as you, when I first heard about what you're doing, I was like, this is brilliant, right? Like the idea that we can genetically engineer plants to provide a benefit for the user, right? Like for the person in their home, right? Like, so I think, like you say, it's been a lot of the problems around GMOs have been the application of the technology, but fundamentally genetic engineering is just a technology, and it can be used for good or bad. It can be used for things that people like and don't like, just like any other technology. And so the fact that you're applying genetic engineering to something that's like beneficial to the end user in a way that I think is much less objectionable than some of the other business practices genetic engineering has been used for is really a great way of kind of not only addressing a very cool problem and like kind of cleaning up the VOCs we're breathing in every day, but also making an impact or a statement about kind of like the positive ways that we can use this technology. And I know that we feel the same way, right? Every bottle and box of ZBiotics is labeled proudly GMO. And the idea that we've applied genetic engineering to solve a problem that you, the end user, have. And so, that genetic engineering is valuable to you in some way that's clearly not unsafe or unsavory in any way, is a way for us to kind of elevate this conversation around genetic engineering above good or bad, or is it or isn't it, into something more understandable and nuanced.
Yeah, and in the interest of communicating with the outside world, so we both have PhDs in the field. Maybe
Right.
it would be interesting to kind of define the terms. What are we talking about when we talk about genetic engineering or synthetic biology? Can you explain it to the layman? What are we doing? How do we create this microbiota or this indoor plant that has this added characteristics? How does that work?
Yeah. Well, I'd love your help on it, but I'll take a first swing at it. Um, Essentially what I'm thinking of when I think of genetic engineering, it's really just changing the genetic code in some way. Really like, and the purpose of that is just to get sort of a new trait or a new function into a living organism, right? And so we've been doing this for intentionally and unintentionally for millennia as humans, right? Like crossbreeding of plants is really just moving genetic information from one plant to another in a way that allows that plant to gain some new function, right? And so whether that's like a juicier tomato or like a redder apple or whatever it might be in the past, now we can just be much more precise about that because we understand genetics better. And so in the case of ZBiotics, we're genetically engineering bacteria. And as with all genetic engineering that's done today in the lab, it's really just harnessing and directing natural processes that living organisms already do to edit DNA. And so in our case, bacteria already take up DNA. They already have systems evolved over the last 3 billion years to uptake DNA from their environment and then essentially swap it into their chromosome, their existing genetic information, in a way that allows them to acquire some new trait. And sort of they do a lot of trial and error to find out whether or not it's helpful or not. And so we essentially direct that process to make sure that we give it a piece of DNA that it then takes up on its own and swaps into its own chromosome, and we can direct exactly where in the genome it goes. We can then sequence it to make sure that exactly what we intended to happen happened and nothing else. And so it's just a lot more precise version than crossbreeding, which is just sort of like mashing a bunch of DNA together and kind of hoping for an outcome that you want without having any clarity into kind of into what initially happened in sort of the genetic crossover event. So genetic engineering, I think, as we refer to it today, is really just a more specific and precise version of how we've been kind of editing plants and animals via crossbreeding for the last several millennia.
And
Yeah,
it also can help us reduce this, well, side effects, because when you're kind of mashing two genomes together or just doing random mutagenesis and traditional breeding, you don't really know what you're doing. You're just hoping for the best and not even testing what's aside from the redness of the apple. You're not really testing for anything else. Whereas with the synthetic biology, you can be much more precise and exactly as you said, sequence and analyze everything you do to make sure there's no unintended side effects. Um,
exactly.
yeah, so it's the same approach that we have at Neoplant is the first step is really looking at nature, being inspired by nature and seeing what DNA parts, what DNA sequences code for a trait, a characteristic that you want to add inside the plant. And in our case, it's bacteria that live in polluted environments. We take the DNA coding for genes that are made to turn pollutants into sugar or into amino acid, optimize them, put it inside our indoor plant, and see if the plant works, if the plant depollutes the air, and just iterate fast on that. And yeah, I think SynBio is kind of the combination
Yeah,
of biology and engineering coming together. And the extra step that both our companies are doing and very, very few others are doing is combining this very deep tech approach with a consumer driven approach, being direct to consumer, being really out there as the GMO synthetic biology company.
right. Yeah, and I think unfortunately, I think synthetic biology is sort of not a very, I don't think it's the right descriptor of what we do. Unfortunately, it's the term that's kind of adopted for the field, right? But like this idea of like synthetic, as if it's like
Mm.
not authentic biology, when in reality, I think we're just better at understanding how biology works, and we can now harness that more efficiently. And so synthetic biology is really just us being more precise about how we edit DNA. But in all cases, we're in some way harnessing a natural process that nature has evolved for gene editing, and has already employed in the process of gene editing over billions of years of evolution. Bacteria, in most cases, are the source of this form of genetic engineering because bacteria are the original gangsters of genetic engineering, right? Like they're the ones that have been doing it the longest. They're the oldest kind of life, older, much older than plants and animals anyway.
Yeah.
So yeah, so I mean, I think that unfortunately, it's sort of like the concept of synthetic biology sounds like we're doing something that is like unnatural, when in reality, it's just a better kind of version of of natural processes of gene change that happen, throughout all life.
Yeah, I completely agree. And everything we do is kind of created by nature, and what we do is kind of fine tune it to have a positive impact. Yeah, that's true that the term synthetic doesn't really apply because everything we do is naturally evolved and we just
Right.
change a few stuff. That is true.
We just have a more clarity into what that looks like now as than we did
Yeah.
even 15 years ago, and so that has enabled a lot. I think it's a good transition to like the idea around like kind of the misconceptions that exist around genetic engineering, right? Like I think that from my perspective, there's a lot of like fear because there's a lot of misinformation and misconceptions about what genetic engineering is, and I think that has created it's sort of like a lot of the ways that genetic engineering has been employed has sort of been conflated with the technology itself, and because of that, there's this belief that by somehow changing the DNA code, that inherently makes the organism unnatural and unsafe. When in reality, like genetic change is a totally normal process, and we're just better at understanding how those processes take place, and therefore can better harness them and direct them in ways that are beneficial to us. And so the idea that, for instance, like Roundup Ready corn is unsafe because of the genetic engineering is not really, it's sort of a disconnect, right? Like the genetic engineering didn't make the corn unsafe in any way. It enabled a business practice of using a lot of pesticides, which you can have the debate about whether or not that's good or bad. And I think there's very reasonable arguments as to why people would not like that and why they are afraid of the extended use of Roundup. But the fact that the product is genetically engineered didn't make it unsafe. It just enabled a business practice that was unsavory. And so you can imagine that if you apply that technology to something like pulling pollutants out of the air, or helping you feel better the day after drinking, or with a probiotic, or something very much more like straightforward and innocuous, then the fact that the DNA code changed is quite normal. It's something
Yeah.
that life already does. So I think that's sort of like the root of kind of like all the misconceptions around genetic engineering and GMOs.
Yeah, I agree. And I think I like to use the analogy of steel. So steel is not bad or good. It depends what you do with it. You can create a sword and kill people with it, or you can create like a stove and cook and feed the world, right? So it's really about a new technology and how we apply it, and we need to be careful about the application itself, not
That is
not the steel.
that is hilarious. I use almost the exact same analogy. I'm laughing because like I often say like metallurgy is a technology, right? And like we use like, you may not like guns. It's a debate about whether on gun control, right? And people who are anti-gun are probably not anti-metallurgy because they recognize that technology can also be used to make a spoon, which is very safe products. Like that's the analogy I always use. So it's really funny that you kind of came to the same sort of analogy, but independently.
Yeah, that's yeah. We did not plan this. Yeah, that's
Yeah.
fun. And so to give a more, I would say, like a better feeling for people, how can synthetic biology change our lives for the better? What kind of are the applications that exist today and that will exist in the next few years? What, how can this synthetic biology or genetic engineering change our lives for the better? So we have the example of a probiotic that allows you to avoid well, this bad feeling, this hangover you have the next day. You have this example of this indoor plant that allows you to have a cleaner air in your home. I'm sure that you have a lot of different ideas application, because once you kind of adopted this bacteria, you can introduce different traits and different characteristics to have different functions. And same thing for our plants. What are other applications of either your technology or other people's technology when it comes to
Yeah,
SynBio that you see happening now and in the near future?
I'm super excited for the space. It's a very exciting time to be a synthetic biologist. I'm thrilled about this. So, at ZBiotics, the idea around the first product was really meant to be a proof of concept, so that people could experience the technology of a genetically engineered probiotic in for a problem that is well understood, that people get, easy to understand, kind of seen as sort of unsolvable. And so, we had to step in with tech to fix it. And there's very nice sort of visceral readout of efficacy for the user, right? They can try the product and really feel its benefit. And so we were really excited about starting there. That being said, the vision for the company is not about kind of making sure everybody feels better the next day after drinking. That just happened to be the first application of genetically engineered probiotics, which when we launched our product in August of 2019, it was the world's first ever genetically engineered probiotic of any kind to go to market for any use case. And so I'm really excited about all the other things that we can build in addition to this. And basically we're focusing on all kinds of things that we can do to help healthy people live healthier, fuller lives, right? So really focusing on places where, like, every part of somebody's day, what are the things that, in a modern life, we just didn't evolve to deal with, right? Like, so humans evolved in an era of scarcity and struggle. And now we sit at computers all day. We don't walk around for, miles a day, and we don't hunt for our food. And we go to the grocery store and it's plenty. There's always enough, and so that often turns in, our reward systems triggered us to eat a lot when food was around, and unfortunately food's always around now. So we sort of, like, there's all these things in our lives that are a product of modern life that are detrimental to our health in some way. And so, air pollution is a good example of something that, even if you're a healthy person and you live a healthy lifestyle, you can't always avoid it. And drinking is sort of a social behavior and normal part of adult social interaction, but obviously not the best for us. And so, what are other things that we can help with and have impact on? I'm really excited about that as a way of sort of getting people excited about what can be done with genetic engineering. So, looking at things like, toxins in our food and water that we can't avoid, like heavy metals in fish, for instance, like thinking about aspects of our diet that are just, like, unavoidable, that are not good for us or for our metabolism or our or inflammation, and these things exist in all of our food products. And so ways that we can sort of channel that or change that into something good. We look at, like, sleep and exercise performance. Like, these are things that we do these days that are definitively good for us, right? But that we don't always do it as effectively, or they have negative outcomes or consequences. Like, if we're traveling, we get jet lag and we don't sleep as well, or we're working hard and we stay up late, right? Then the next day is kind of messed up. And so, what are things we can do to help your body deal with that? Or, like, how do we help you deal with, like, the soreness and pain after exercise, so that it doesn't delay your progress? So I think there are just, like, so many cool things that we can do, kind of, as healthy people, kind of deal with, like, the annoyances and problems of, like, living a healthy life in kind of, like, the modern world. So that's some of the things that we're excited about ZBiotics. And then when I look more broadly, I think about, like, there's just incredible things that people are doing with genetic engineering to help humanity live more sustainably on this planet. So I see, companies that are using microbes and genetically engineering them to make products that we traditionally get from agriculture, from plants. And so, mowing down rainforest to plant palm trees so that we can get palm oil, which goes into, like, something like 70% of the products in their grocery store. Instead, we could use a microbe to make that palm oil. And, so basically, in a bioreactor the size of your refrigerator, we can, replace hundreds of acres of palm trees. And so, that's rainforest we don't have to mow down. And so, much more sustainable way to develop products like that. I've seen the same for, literally, there are companies that, I mean, it just blows my mind they do this. They basically engineer microbes to take pollution out of the air, like CO2 from the air, fix it into all kinds of useful products like fish food or bioplastics or all kinds of things. So like literally turning pollution into a useful product. So in one fell swoop, a more sustainable version of whatever product they're making, and also like removing carbon negative. So I think that like these are the exciting things. Like as we look at feeding a growing population of people and climate change and like dealing with emerging infectious diseases, the idea that we can engineer organisms to kind of help solve these problems for us that we have created, right? It's like leaning into the technology as a way of kind of like of going back, and now that we understand more about our impact on the environment, then now leveraging technology to reduce that impact, I think is like a really exciting thing. So, making healthy people healthier, making sick people healthy, and like healing the planet, I think are all things that are possible with this tech. And I'm really excited about that.
Yeah.
But I'm sure you've got lots of things that you've got kind of on your radar. I'd love to hear about that.
Yeah. Sometimes when we talk about this, it sounds kind of like magic. Like, how come all these things are happening right now in
Yeah.
different little startups and different companies? Why? How didn't we think about it before? And I guess what I tell people is it's always been there. The technology has always been here. It's been developed for the last 4 billion years, just not by humans, by nature. It took
Totally.
4 billion years to develop this technology. So we're just kind of piggybacking and just doing the kind of not last mile, last centimeter compared to what nature has done. And we can kind of shape it to what we think is best. And I think the example that you gave of solving problem that was caused by, well, our oversights, our overuse of machine, our overuse of resources is definitely something that nature is really good at. And so synthetic biology can really help for that. So in our case, it's, well, these pollutants are not supposed to be anywhere near us. We're not supposed to
Right.
breathe in formaldehyde or benzene or stuff like this every day. So it's what we do is that look at nature and add these genes, these technologies, and just solve the problem. We can think about this exact same approach to absorb more CO2 from the air. So creating super trees or super plants that absorb more CO2, store them longer, have wood that doesn't degrade, or have deeper roots, or even produce molecules through the roots. So absorbing the CO2 from the tree and producing molecules in the roots that don't degrade in the soil. You can create also plants or bacteria that help the plants to absorb nitrogen more efficiently. So you don't have to use synthetic fertilizers, which is a huge problem for air pollution, soil pollution, water pollution. And these are all technologies that different companies are working on right now.
Yeah.
And yeah, it's a very exciting time. And it's with the advancement of the latest kind of technologies that we're able to kind of, leverage what nature has developed so far. Yeah, and there's a bunch of other cool tech that is coming up in the next 5 and 10 years, and I'm really looking forward to when they hit the market, because we're kind of the first wave, and when there's going to be a big wave of things coming, I think the look that people will have like, okay, we didn't see this coming. It's going to be kind of like the internet or kind of like computers, like this huge wave of innovation that we didn't see coming. But this innovation sounds like magic, but when you are on the backstage, it's a hell to work with. It's so much
Yeah.
more difficult to work with mushy stuff and organisms compared to hardware, software, coding with
Totally.
just yeah. So tell me about like kind of a horror story. What's like the biggest difficulty you faced creating this magical organism?
Yeah, I think that the biggest difficulty that we faced was honestly, and I was surprised about this, was really in scaling up the manufacturing of it, right? So, like, engineering the bacteria itself was pretty straightforward. As we described, it's really just kind of it feels a lot like going downstream, right? We're already leveraging, the bacteria's ability to take up the DNA. It has all the machinery to edit its own DNA, and so just sort of like we're basically creating an event that probably already happened in nature, billions or trillions of times. But it wasn't particularly useful to the bacteria. And so it didn't necessarily persist. And so now it's useful to us. So we're sort of like, hey, like do that again and we'll use you. And so that part felt pretty, there was not a lot of resistance from nature for that. That part went pretty smoothly. But then what I was surprised about was sort of like, humans have been growing bacteria for millennia, right? Like fermented foods, and then like more recently in kind of like beer and wine and stuff, right? Like that's yeast, but growing microbes in these big bioreactors, and then we grow these like probiotics and stuff. So I figured, look, we have a bacteria that is pretty easy to grow, and this will be no problem. And it's been surprising to me that the infrastructure for synthetic biology just in hindsight, this sounds obvious, but I didn't consider it when I started the company, that the infrastructure for synthetic biology doesn't exist right now. And so the idea that somebody would grow your strain that you have, rather than like just this like white labeled list of bacteria that they already grow, was more challenging than I thought it would be to get people to get like kind of like the manufacturers on board and stuff. And so we really had to, because we were the world's first, we had to, and I'm sure you're experiencing the same. It's like had to blaze our own trails here, like in terms of a lot of the sort of infrastructure and manufacturing and supply chain that I was not anticipating. And so that's been a huge headache. And I think I'm excited about as the industry grows, we kind of build that infrastructure, and we have an opportunity here to build it in a way that's aligned with the values of the industry, which is around, a lot of it is around sustainability and accessibility. And so building an industry that is in line with that, I think is another exciting opportunity that we have. The bioeconomy is one that will be a better kind of built better than kind of previous industries, industrial and chemical, because we know more, which is really excellent.
Yeah, and something that I'm very optimistic about the field because of the people that are in it. When you talk to other founders, other people working in synthetic biology, they all have front and center, let's have a positive impact in the world we live in. And this is very
Yes.
encouraging. I think it's something that I love about the industry, this fledgling kind of industry. I think is led, at least this wave is led by really smart people and people that really want to have a positive impact in the world. And yeah, it's but the problem also of being the first, it's very exciting to see this kind of new community around it. But as you said, we have to develop new things all the time because the field is not mature yet. So for us, the biggest difficulty was trying to understand the plant. It's a plant that very few people have worked on, and developing the tools and just sequencing the genome,
Yeah.
understanding which tools can we apply to that plant, and even the tools themselves that can be applied to any plant or even any organism haven't been developed yet. So we had to, oh, okay, so let's take a step back and just do the basic research, the basic science, the tool building in parallel of building a product as fast as you can and the best product possible, because you want people to, what we're building is kind of the first thing people will see when it comes to engineering and synthetic biology. You want it to have a positive impact on people's minds. So you want to create a great product that people can really relate to and see the potential of. And so building this product as fast and as well as you can, while building the fundamental science tools that you need to build the product, was a very big challenge. Even testing, I'm sure that you had difficulty of,
Yes.
okay, how do you test the product? Because nobody has, when you're testing a tire for a car, like there's ISO norms, there's people you can pay to test your product. You can't
Right.
pay people to test our product. You need to develop the testing facilities as well. And yeah, it's been a challenge, and it's still a challenge for us to do everything at the same time, to kind of reinvent everything in parallel of building a product.
No, totally. I deeply empathize with that. You're absolutely right. We had to like, there wasn't, standards, right? For like,
Yeah.
how do you know if it's working, right? And like whatever. And so we had to come up with a whole list of things. Our quality program is totally novel and bespoke to what we're building because the industry didn't exist before. And so like we are like, because I'm sure you feel the same as like somebody who's kind of on the forefront of a new industry, that you kind of are responsible for defining, I think, what a gold standard is, where the bar should be. And so, for instance, a good example of this for us was, in the probiotics industry as it currently exists, you sort of just take these bacteria that are the leftovers of the dairy industry or whatever, and then you kind of just grow them up in kind of an old and antiquated way, and then you put them into a pill, and you don't really worry about what's in there because it's just kind of like the product of fermentation. And so there wasn't a lot of kind of quality checks on that. And so we started working with these manufacturers that traditionally done regular probiotics as opposed to our genetically engineered ones, is that they had very little kind of purity and quality standards. And so then when we come in and simply just do a next gen sequence, so like just sequence all the DNA that's in the material they give us, we started to see that these providers, were running operations where they were getting all kinds of things that were coming in, and they weren't unsafe, but it wasn't pure, right? It was just
Mm,
other strains that they were growing were kind of like cross contaminating, and they just had never really checked for these things at the level of rigor that we were, and bringing a sort of like a synthetic biology approach to it, and like really thinking about like we want these products to be perfect,
mm.
because like we're defining a new industry, and so that trying to figure out kind of where we establish quality standards, and how we establish that our product is working sufficiently, and all those things are things that we had to kind of develop on the fly, and that has been a big challenge, but a fun one as well, kind of is in defining the industry. So
I think
and I appreciate kind of your headache that I'm grateful we didn't have to deal with, was that you had to do a lot of discovery biology yourself to learn like the tools and the nature of the plant you're working with. We were able to at least slot into a bacteria that had already been really well studied. So there's a lot understood about its biology, and so you had to do a lot of extra legwork there. But hard problems are good ones for business. So
I think it's super interesting as a scientist, all the problems that you have, like, oh, I need to solve this and that.
yeah, yeah,
But as a CTO, I'm like, okay, this is complex. I need to
yeah,
solve it because I have a deadline. I need to ship the product, etc. So it's
right,
very interesting challenges, but it's always like, I wish people have done that before. Like, why do I have to do this? Like, at
totally,
least
totally,
part of it, yeah. Uh, but yeah, switching back to something more fun. So we talked about the kind of the applications that people are working on right now. If you fast forward like 20 years, what do you see SynBio? Like, pitch me the dream.
yeah. It's fun. I'm excited to hear your version of this too. I think that 20 years from now, we're I think that this becomes, much like, I mean, if you look 20 years back, right, and like, the difference between how we think about computers and the internet today, as we did kind of, then I kind of think that's where we are right now, right? Like kind of the precipice of this like bioeconomy and these biosolutions, and products to kind of come into the forefront. And so I think 20 years from now, we're going to see that this is deeply integrated into how we live our lives. So you walk into the grocery store and you're looking for, genetically engineered products because they're better, they're, cleaner, they're more sustainable. And so I think that that's our future, right? That like products that are, there's clear definitions about what's expected of responsible engineering, and those are being applied to make products that enable kind of people in all sorts of ways, in terms of their nutrition, in terms of like their lifestyle, and in terms of like their environment. All these things are made better. And so I think our energy utilization, our materials manufacturing, our without a doubt, our medicine, right, and our food are all things that will be made better by like a better understanding of biology. I think to date, in the modern world, in the last like 150 years, we have been actively working against nature. And in fact, if you even look back 10,000 years, the dawn of agriculture as we currently know it, all of that is kind of nothing is more unnatural than planting rows of crops. Like agriculture is one of the most unnatural things we've done to this planet as humanity. And we think of a farm as a natural place, but it's a very unnatural thing. We mow down all this biodiversity and all these forests, and we plant rows and rows of whatever, of strawberries or nuts or whatever it is. And that is very much unnatural. And so I think that we are coming to realize that the agriculture and a lot of the practices that we do are unnatural. And so I think in the next 20 years, the applications of biotechnology are ways for us to sort of correct that and start working with nature rather than against it, in order to be a better, kind of more responsible part of the planet.
I'm laughing because this is exactly what we say, working with nature instead of against it. That's exactly right. And I think the beauty of nature, it's a self-propagating organism. Once you build one machine, you just leave it and it just grows to many millions of machines, right? So scalability is inherent in the organism and much more sustainable for sure. When I think about the future, I'm a huge fan of sci-fi. So when I think about the future, I think about like space and stuff like this. And even there, like you could imagine in 20 years that instead of sending like a huge bunch of medicine into space when we're going to colonize the moon and Mars, you can send just very small bacteria that produce these medicine whenever you want, even for your own life, because I think it's going to start with this kind of edge application. But then instead of going to the pharmacy, you have kind of your own little bioreactor and you click a button, I want penicillin. And a few hours later, you'll have your penicillin pill that's been built by your microbes inside the bioreactor. I think self-healing materials is going to be very interesting
Mhm.
because you could create like skin-like material. If you can recreate biology, why not recreate like the way material just repair themselves so we don't have to throw them away, etc. Yeah, I think there's a lot of really cool application coming down the drain, and I think in 100 or 1,000 years, I think the world will be unrecognizable, like because we'll live so much more sustainably with these kind of technologies. I think we'll replace a lot of. I think everything that you do right now will be replaced by SymBio in a way or another. Maybe with the exception of electronics, computers, and stuff like this, where I think machines are still better for now.
Yeah, and I
The
think but that'll be really interesting, right? There's a lot of for instance, a good example of sort of biology kind of showing its strength relative to machines is like data storage, right? Like DNA is a much more efficient form of data storage than what we currently use with computers and chips. And so it's possible that I think that like these will likely start to come together, and we'll have like sort of these like bio machines where we're harnessing kind of biological processes that are really efficient, right? Like humans have only been innovating in the machine space for a couple hundred, in terms of like motorized or electronic machines, right, for like 100 years or two, right? And um uh biology has been kind of like engineering super efficient, super complex machines that do millions of functions every second, right, for 3 billion, 4 billion years. So that is really, I think, where I think as we get smarter and we understand more about how biology works, I mean, that's the ultimate technology. And I think that, to your point, 100 or 1,000 years from now, I see us being totally, pictures of the far future are always like, white, like metal, like, buildings and stuff, right? And I don't think that's going to be the case. I think that like,
yeah.
it's going to be far more about like homeostasis with nature and applying nature in ways that help us live like more effectively and efficiently than ever before.
Yeah, I think the way we see the future is like the Jetson, how they saw the
Yeah.
future in the like
Yeah.
60s, etc. It's just
Right.
with
That's the 50s,
this
right? And the
technology.
industrial
Yeah,
revolution, like, and like, people are, well, obviously 50s is after industrial, but like when it was all about chemistry and manufacturing and, whatever, it's like, that's their version of the future. But I think the biological future is very different.
exactly.
Okay. I think that's a good transition into like a fun question, which is, if you had a time machine, when and where would you travel to kind of for inspiration, like given where you are right now?
In the past, you mean?
Yeah. Yeah. Yeah.
Yeah.
I guess the
So
future, that's probably harder to predict.
that is true. If I had to go back for inspiration, for me it will be the very beginning of the computer companies, like the computer science thing in the late 50s, 60s, maybe early 70s, because this was a completely new field when we're talking about hardware and software coming together. What type of applications? Can you imagine the computer of tomorrow? Like instead of this big room, it will be this small little thing in your pocket, etc. I think there's a few things that could inspire us. First is trying to imagine where this technology can go and build according to that. And and second, everything they had to put in place, the way of working, the agile methodology, they had to reinvent a new way of working that was very different from normal factories and just yeah, like working in chains. And it was just a new way of thinking about innovation. And I think they got a lot of things right. And I would love to be a fly on the wall on these discussions. So, okay, how do we create a structure to our software? How do we have standardized way to talk about things? Because right now in each lab we have our own kind of artisanal way to do things. It's very difficult to communicate. It's like the tools are not very transferable. It really is the very beginning of this field and still artisanal in some way. So I'd love to be a fly on the wall at the yeah 60s in computer science companies like Intel, IBM, maybe Microsoft. It will be very interesting to see the discussions, the very early discussions when they were like us, like 30 people in the company. And so, yeah, I would love to be there. Yeah.
Yeah, I love that. It makes perfect sense for kind of what you're building, right? Like, yeah, I think all that era was all about moving a very kind of early and primitive technology kind of along, but then also putting it into like into people's hands, right? In a lot of ways,
Yes,
right? Like in
yes,
businesses and
definitely.
homes. And that's exactly, what you're doing at Neoplants, right? Like you take this like complex and sort of new technology around genetic engineering and then making something that you can then functions in somebody's home for them and like that they engage with. And so I think that makes perfect sense. And similarly, I think for me, um, I think the place I want to go is kind of like in the 20s and 30s when there's sort of like this like boom in sort of chemistry being applied to consumer problems, right? Like so like there was like kind of fundamental discovery around chemistry, and then there was like all these incredible innovations with like polymers and things that like totally changed the way that consumer products were invented and were brought to market, and what problems they solved and how we apply this technology, right, to like things like nylon and polymers and all materials and all these really exciting things. And I think I'd love to go back and see the thought processes behind like what, like you have this like massive tool now, right, with chemistry, to like solve all kinds of problems. And how did you focus and what did you write? Like, it hit every industry, right? We built better drugs, we built better materials, we like improved agriculture. I mean, we're kind of dealing with the problems of that improvement now. And so I think that those are things that, like there was, I think that's an important question too, is like, were people asking, what questions were they asking? And what questions weren't they asking, like with the impact of their technology? And so I think that these are lessons hard learned for humanity today, that we're trying to apply for biotechnology, for the new kind of wave of technology. But I would love to go back and kind of see how people were thinking about that, both from the standpoint of innovation and from the standpoint of impact. I think there'd be just a lot of lessons to learn in that time, and that we could apply analogously to that.
Yeah, yeah, and as you said, also the errors, the oversights they had also to, yeah, about impact and see, do we have anything that we're overseeing? Is there something similar
Yeah,
that we're not thinking of? Yeah, for sure. Yeah, I think our ancestors did as good of a job as they could, and I think it's up to us to kind of, okay, let's
do
do
better.
better now. Yeah,
Yeah,
because the
we've learned.
yeah,
Hopefully.
the agricultural revolution allowed us to go from 1 billion to 8 billion now people on the planet. So it's not nothing. It had a lot of negative consequences, but I think people would agree, net positive if you can 8x the amount of people on the planet. But now it's time to, okay, now we're a lot of people. There's a lot of negative consequences. Let's change the way we do things. Yeah, totally agree. And yeah, this has been a fantastic adventure, I think. And
Yeah.
we talked about the challenges. What is the one highlight, the one great memory that you had from, how long has it been, by the way, for ZBiotics?
We started in um 2016, so it's been like a little over 7 years. Yeah.
Yeah, yeah, for us it's 5. Yeah, so in those 7 years, what's like the one memory, the one highlight that sticks with you?
I mean, there's been a lot of really fun moments. I think, launching the world's first genetic engineered probiotic was something that I was, it was what we set out to do. And I was like thrilled when it actually happened. It sort of felt like a dream come true. But I think that like the moment of like, probably like the moment of sheer joy, um, that there were several milestones that I really like to kind of come up here for me, and like like getting like 1 million bottles and making
Mm.
$1 million and like kind of all these like numbers but like I think that like the the moment that was like the most exciting probably was I was like just alone in the lab, and I had been just like slamming my head against the wall for months, trying to work through this like technical challenge to get the bacteria to express this protein. And I had been like overlooking something, like as is the case a lot of times with science, right? Like this thing that is sort of like staring me in the face that I kept ignoring, and it kept causing problems. And then finally I had this like aha moment that like, wait a minute, it probably this thing. And so then I changed it, and took a new approach. And then the moment that I saw the bacteria make our enzyme, like I saw it on the gel, of the enzyme that breaks down acetaldehyde, like when that like after having just like hundreds, literally hundreds of gels come up without that brand, that moment, and then seeing it for the first time, I literally like she was jumping in the air and like, just like woo, like so excited. Like it felt like I just won the Super Bowl. It was like one of the greatest feelings like I'd ever had. It was a really incredible moment. So for me, I guess it was that moment at the bench when kind of things went right finally. And we had this thing in hand, and I think that felt really really good. So that's been one of the big highlights for me.
Yeah, I completely empathize. When you have a good results in the lab, everybody's super energized, and yeah, it changes the way you think about the journey because it is a roller coaster. There's days where it's nothing's
Yeah,
working, everything's going to
right.
shit, we're all gonna fail. Then there's
Yeah,
days where you have those win and you just yes,
yeah,
savor them. Yeah, I guess for me the highlights. I'm not going to talk about something that is technical. I really have very fond memories at the very, very early stages when it was just me and my co-founder, Leo. Uh, the first time we kind of sat down and like, okay, let's pitch this crazy idea. How do we pitch this to investor? How do you pitch something that really doesn't exist, or even the category of the concept doesn't really exist in people's mind? And trying to craft the speech that okay, how do you explain this to investors, to people,
yeah,
etc., kind of defining really how what we do and how to talk about what we do and going to fundraise, and that was the most exciting time for me. Yeah.
totally. I mean, how about like when you finally get it right and you see somebody's eyes light up and they like you see that they get what you're trying to accomplish. I know that
Oh
that's like a
yeah.
big thrill. Yeah,
Yeah, yeah.
yeah,
Every time when you explain to people what you're trying to do, yeah, I think this is it's not one highlight. It's the thing that keeps me going is when you explain people what you're doing, the response that people
yeah,
have, just the initial, even if they don't understand everything, the initial response is something that keeps not only me but the whole team going. That's for sure. Yeah.
totally. Yeah, seeing the excitement when people like
Mm.
see your vision and are excited about it, like customers or friends or investors or whatever it is, and that
Yeah.
is an incredible feeling that like the world is is engaging with your science, right? Like we're scientists and we spend a lot of time in the lab, like in those private moments, looking
Yeah.
at gels, right? But it's really amazing when kind of the world can share in that. And so you're right that I
Yeah.
think more than anything, that's uh that's what makes this job fun.
Yeah, and explaining, yeah, what we do and why is it good, etc. Yeah, this I think this is why we do what we do is to put just a smile on people's faces and trying to better their lives. And
Totally.
yeah, on that point, Zach, it's a great discussion. Thank you so much for spending the time with me.
Oh man, thank you so much, Patrick. This is a blast. I definitely want to do it again. All right,
Yeah,
cool.
yeah,
Good.
that's okay. And yeah, good luck with everything going forward with ZBiotics. I'm a huge fan of what you guys are doing, and yeah, looking forward to what you're going to do next. Really, I really do.
Likewise. I mean, I can't wait to get my Neoplant. So I'm
Good.
stoked about all the things that are happening over there.
Uh,
So it's
Our launch
it's
is
an exciting
still,
time.
yeah, our launch is still down the road, so we're still a bit earlier than you guys, but we hope to get where you guys are. All right. So
Yeah.
yeah, thank you so much, Zach, and have a great day.
Yeah. Likewise. Chat later.